Dear students, a very good morning to one and all. Now I will explain about how to convert the given context free grammar into push down automata. That means CFG to PDA conversion. In this point of view, we will follow here two rules. Before we will move to the rules, first we will convert the given context free grammar into GNF. Already we know how to convert the grammar into GNF, Greeback normal form. So GNF means the left side production rule is any variable. In the right side, starting with terminals. After the terminal, any variables, any number of variables is accepted. That is GNF. Already we know the GNF format. So our aim is to convert the CFG to PDA. In this point of view, first we will convert the given grammar into Greeback normal form. Okay. Next, we will follow two rules. The first rule is suppose in our grammar, if there are non-terminals, definitely in each and every grammar, non-terminals are there and terminals are there. So for non-terminals, what we will do here, add following rule. What the rule? Suppose the production rule, capital A implies alpha. In that we will consider, simply we will consider this transition function delta of q comma epsilon comma capital A is equal to q comma alpha. Suppose we have the production rule capital A implies small a capital B. Small a capital B means this is in GNF format, no problem. So simply we will write the transition function delta of q comma epsilon comma capital A is equal to q comma AB. Okay, so the left hand side we will write here, the right hand side we will write here. Very simple. Okay, so this is the non-terminal symbols. Suppose definitely in the grammar we have some terminals. Okay, so for terminal symbols we will add the production rule delta of q comma a is equal to q comma epsilon. Here small a is the terminal symbol. Okay, so that's why we will write in this format. Suppose in our grammar some terminal symbols like small b comma small c, then we will write simply the first transition function as q comma b is equal to q comma epsilon, like that. So here c is also terminal symbol, so simply we will write like this. Okay, so with the help of these rules we will convert any grammar into the PDA format. Okay, so just remember these two rules. Now we will solve one problem. So here I will consider the grammar construct PDA for the given context free grammar. Here the grammar is S implies 0 BB, B implies 0S, 1S, 0. Okay, already we know what is the meaning of PDA, what is the meaning of CFG. CFG means finite set of variables, finite set of terminals, production rules, starting symbol. Okay, here the starting symbol is capital S. Here the variables are capital S and capital B are the variables, 0 and 1 are the terminals. Now we will convert this context free grammar into PDA. So already we know what is the meaning of PDA. PDA is a collection of 7 tuple, finite set of states, finite set of input symbols, transition function, starting state, set of final states, shy indicate stack alphabets, stack symbol. Okay, so now we will convert this grammar into PDA format. Okay, So let us start with the grammar. Here S is the starting symbol. So here we have the production rule. S implies 0 BB. So what is first rule? Before we will move to the first rule, first we will convert the given context free grammar into GNF. Already this grammar is in GNF format. Okay, that's why we will consider the first rule. Capital A implies alpha. So here S implies 0 BB. Simply we will write, okay, so what, delta of Q comma epsilon, here the left hand side is capital S, is equal to Q comma, what is the right hand side, 0 BB. Okay, so for this production rule the PDA format is, this is the PDA format. Okay, so now we will consider the second production rule, that is B implies 0S. Okay, so here also left hand side right hand side available, that's why simply we will write delta of Q comma epsilon comma S is equal to, sorry, B. Okay, here B is equal to Q comma 0S. Okay, what is the third production rule? B implies 1S. Okay, so here the left hand side is there, right hand side is also there. Already this is in GNF format. So simply we will write the production rule, Q comma epsilon comma B is equal to Q comma 1S. Okay, so next the fourth production rule, B implies 0. Simply we will write Q comma epsilon comma B is equal to Q comma 0. It's an F. Okay, so here we have 4 production rules. Here we will solve the 4 transition functions for each production rule. This is the transition function. Okay, so that is rule 1. Now we will move to the second rule for terminal symbols. Actually here 0 and 1 are the terminal symbols, so we will consider this as the special case. Okay, after these 5 transition functions, now we will consider the 5th transition function as why the 5th transition function? Because here 0 and 1 are the terminal symbols. So first we will consider the terminal symbol 0. Okay, so already we know the rule for terminal symbols. Simply we will write delta of Q comma A is equal to Q comma epsilon. So here the terminal symbol is 0, that's why we will simply write Q comma 0 is equal to Q comma epsilon. So another terminal is also there, that is 1. Okay, for terminal symbol 1, simply we will write delta of Q comma 1 is equal to Q comma epsilon. Okay, so this is the conversion of CFG to PDA. Finally the PDA is, okay, what is the first one? Delta of Q comma epsilon comma S is equal to Q comma 0 BB. Second one, delta of Q comma epsilon comma B is equal to Q comma 0S. Third one, delta of Q comma epsilon comma B is equal to Q comma 1S. Fourth one, delta of Q comma epsilon comma B is equal to Q comma 0. Already we have these solutions. Okay, so next 5th one, for terminal symbol 0, delta of Q comma 0 is equal to Q comma epsilon. 6th one, delta of Q comma 1 is equal to Q comma epsilon. Okay, so this is the PDA. Okay, thank you.